Okay, so on the gravity part, we talked about the difference between mass and weight. So weight is a factor that depends on gravitational pull. So if we're standing on our planet, Earth, then we're going to weigh a certain amount. But if we then go to the moon and weigh ourselves on that, then we're going to weigh less than we weigh on the Earth. That's because larger objects have a greater gravitational pull than smaller objects. So we could say like the Earth attracts us to it even more than the moon would. So we would be lighter on the moon. And Jupiter is even larger than the Earth. So we would weigh even more on Jupiter, because Jupiter would have a greater gravitational pull on us than the Earth, and also a much greater gravitational pull than the moon has on us. But mass is just a measurement of how many atoms we have in us. So we know all about cells, we know all about DNA, we know all about all the organs of the body. Well, all of those organs are made up of atoms. And atoms have mass. And so that's what mass is a measurement of, is all the atoms in our body. So no matter what planet we're on, whether it's Earth or Jupiter, we're going to have the same mass. Our cells and our physical features, all these things are not going to change. So we'll still have the same mass as we did no matter where we are. But we usually do measure mass, like here on Earth, because we don't have to deal with different planets. We do measure mass using the same scales we'd use measure weight, because it's going to be the same on a certain planet. Now, it might vary just a tiny bit in different locations on the Earth. Like, let's say, if we're up on a mountain versus, on sea level, things might actually weigh differently. But for the most part, that amount is so negligible that most people don't need to worry about those things.